Welcome to the first lesson of the Integer Properties module. In a nutshell, the topic of integer properties is related to how the composition of an integer affects its characteristics and the way it behaves. One of the central themes of integer properties is divisibility. Now, if x and y are integers, then we will say that x is divisible by y if there is no remainder when x is divided by y. For example, 30 is divisible by 5, since 30 divided by 5 gives us a quotient of 6 with no remainder. Similarly, 12 is divisible by 3, since 12 divided by 3 is equal to 4 with no remainder. Conversely, 8 is not divisible by 5, since 8 divided by 5 is equal to 1 with remainder 3. Now, another way to define divisibility is to say that if x and y are integers, then x is divisible by y if there exists some integer k such that x is equal to k times y. For example, 16 is divisible by 6 since 16 can be expressed as 8 times 2, where 8 is an integer. Similarly, 18 is divisible by negative 3, since 18 can be expressed as negative 6 times negative 3, where negative 6 is an integer. Now, please keep in mind that although the concept of divisibility applies to all integers, the GRE typically restricts divisibility questions to positive integers. Okay, one last example. 40 is not divisible by 14 since there exists no integer k such that 40 is equal to 14 times k. Okay, let's examine some more definitions. If x is divisible by y, then we can say that y is a divisor of x. Or if x is divisible by y, we can say that y is a factor of x. The terms divisor and factor mean the same thing, and the GRE will use these terms interchangeably. So we can say that 4 is a divisor of 8, and we can say that negative 10 is a factor of 40. Now, although negative 10 is indeed a factor of 40, you will find that GRE questions typically focus on positive divisors. Okay, one last one. 15 is not a divisor of 20. Alright, now let's practice our knowledge of divisors. What are the positive divisors of 12? Well, the positive divisors of 12 are 1, 2, 3, 4, 6, and 12. All of these integers divide into 12 without leaving a remainder. Notice that the positive divisors of 12 include 1 and 12. As you might imagine, every integer n will have 1 and n as its positive divisors. Alright, to continue, the positive divisors of 9 are 1, 3, and 9. What about 60? What are the positive divisors of 60? Well, let's list them. Now, sometimes when we list positive divisors, it's possible to miss some. One way to avoid this mistake is to list the divisors in pairs. By pairs, I mean two integers that have a product of 60. Now, we'll begin with 1 and work our way up to 60. Since 1 times 60 equals 60, we know that 60 is another divisor. Working our way up, we should recognize that 2 is a divisor of 60. Since 30 combines with 2 to get a product of 60, we know that 30 is another divisor. The next divisor is 3, and it pairs with 20 to get a product of 60. Next we have 4, and its pair 15, and then there's 5, and its pair 12. Notice that each number and its pair are getting closer to one another. When they meet, we will know that we have found all of the divisors. Now, the next divisor of 60 is 6, and its pair is 10. Now, at this point, we haven't finished listing the factors just yet. There are still some numbers between 6 and 10 that we must check. Now, 7 is not a divisor of 60, and neither are 8 and 9. So our list is now complete, and we can see that 60 has a total of 12 positive divisors. Now, another term we should be familiar with is that of multiples. If x is divisible by y, then x is a multiple of y. For example, since 14 is divisible by 7, we can say that 14 is a multiple of 7. Similarly, since negative 36 is divisible by 3, we can say that negative 36 is a multiple of 3. To expand on this, we can say that the multiples of 10 are as follows. Similarly, we can say that the multiples of 6 are shown here. Now, although these multiples include negative values as well as 0, you will find that GRE questions typically focus on positive multiples. Alright, let's summarize. In this lesson, we have seen several different terms related to the concept of divisibility. All of these terms provide us with different ways to say the same thing. For example, if x and y are integers, saying that x is divisible by y is the same as saying when x is divided by y, the remainder is 0. Another way to say this is y is a divisor of x. Or we can say that y is a factor of x. Or we can say that x equals k times y for some integer k. Or we can say that x is a multiple of y. All of these statements are conveying the same idea. Later in this module, we will add even more statements that are equivalent to these ones. Now, in many cases, your ability to solve an integer properties question will depend on your ability to recognize that these statements are all interchangeable. So be sure to be aware of all of the different ways to express the idea that one number is divisible by another number.